Hey there. You know that calculator you've probably had since high school? The one you use for basic math or maybe to split a check? Well, what if I told you that inside that little plastic box is a secret genius, a seriously powerful problem solver you've probably never even met? Today, we're going to unlock its true potential.
So, here's the big question. We all trust it to find x for us in an equation, but have you ever stopped to wonder how it does that? Is it just spinning out a pre-programmed answer, or is there some kind of logical process happening in there? We're going to pull back the curtain and find out if your calculator can actually think. All right, so we're going to ditch the boring plus and minus stuff. We're diving deep into these hidden equation modes that can solve some really complex problems in just a few seconds. And honestly, these are strategies that might just change how you see both your calculator and math itself. First up, a classic from algebra class. Remember these? Simultaneous equations. You got a couple of equations, a couple of unknowns, like x and y, and you got to find the one set of values that makes them both true. Let's see how the calculator just crushes this. Okay, so the process is actually super simple. Once you're in the right mode, you just punch in the coefficients, the numbers in front of the variables and the one at the end. So for our example, that's 2, 3, 10 for the first one, and 1, -2, and 6 for the second. You hit execute, and bam! It just gives you the answer. All that tedious algebra we had to do by hand, gone. And here's a real pro tip for you. Don't just scribble the answer down on paper. You can actually store the solutions for x and y right into the calculator's memory as variables like a and b. If you're working on a big multi-step problem, this is an absolute game changer. It'll save you so much time and prevent silly mistakes. Okay, time to level up. Let's talk polynomials. You know those equations with the little powers like x squared or x cubed? Finding their roots, which are just the values of x that make the whole thing equal 0, can be a real pain. But for your calculator, it's just another Tuesday. And you probably guessed it, the process is pretty much the same. You jump into the polynomial solver, you tell it the degree, so the highest power in the equation, which is 2 for quadratic, and then you just pop in the coefficients. Hit execute, and it does all the hard work for you. And boom, there they are. For this equation, the two values for x that work are 2 and 8. Simple, right? Clean, fast. But, and this is a big but, this is where most of us stop. We get the numbers, we write them down, we move on. But your calculator knows a deeper secret about these numbers. Get ready, because this right here, this is the aha moment. The numbers themselves are really only half the story. The real magic happens when we ask one simple question.
Yeah, what are 2 and 8, really? They're not just random answers to a math problem, they represent something real, something you can actually see.
And here it is. Those roots, 2 and 8, they are the exact spots where the graph of this equation, that classic U-shaped parabola, crosses the horizontal x-axis. This is the bridge that connects abstract algebra to visual geometry, and your calculator gets it completely. But wait, it doesn't stop there. Seriously, after it shows you those two roots, if you press the button again, it reveals another crucial piece of the puzzle about that curve. Press execute one more time, and it spits out another coordinate, an x value of 5, and then a y value of -9. So what in the world is this point 5, -9? That, my friends, is the vertex, the absolute lowest point of that U-shaped curve. Your calculator isn't just solving for where the graph hits 0, it's analyzing the entire shape of the function to find its turning point. That's a fundamental concept in calculus, and it's all just happening right there in the background. Okay, now for the final boss, the ultimate power-up, the general solver. This is the mode that can handle pretty much any equation you can dream up, even the weird ones that aren't nice, clean polynomials. Using it is a piece of cake. You just type in your equation, and here's a neat little shortcut. If your equation is set to equal 0, you can just leave that part out. The calculator just knows. But then, after you type it in, something interesting happens. The calculator asks you a question. It'll ask you for an initial value. What does that even mean? Well, it's basically the calculator saying, hey, I'm about to go on a hunt for the answer. Where do you want me to start looking? Give me a starting guess. And that one little question is the key to this whole thing. And that brings us to the final reveal. We are finally about to answer our big question. Does the calculator think? Well, instead of me telling you, let's just watch its process.
See, it's not magic. It's just playing a very, very intelligent guessing game. So let's say you give it a starting guess of 0 for the equation 2x plus 10. It plugs in 0, the answer is 10. The calculator goes, nope, that's not 0, try again. Then it makes a tiny smart adjustment to its guess, checks again, sees if it got closer, and adjusts again. It keeps doing this, refining its guess over and over, thousands of times a second, until the difference between the left side and the right side is 0. And that's when it knows it's found the answer.
This incredibly powerful systematic process of guessing and refining actually has a name. It's called Newton's method. It's not just guessing randomly in the dark. Each new guess is mathematically designed to be better than the last one. It's an algorithm, a structured way of thinking through a problem to get closer and closer to the perfect solution.
So let's just recap the absolute genius we've unlocked today. Your calculator is so much more than a number cruncher. It's a sophisticated tool that solves systems of equations, it finds the roots of complex polynomials, and it even shows you the secret geometric life of those equations, like their highest and lowest points. And at the very heart of it all, it uses this powerful iterative process to literally think its way to the right answer.
So, does it think? Well, it doesn't just know the answer. It has a method for finding it. It tests an idea, it learns from its mistakes, and it refines its approach until the problem is solved. So the real question isn't whether your calculator can think. It's, now that you know how it thinks, what new and interesting problems are you going to challenge it to solve?